Hello students, in today's video I'm going to cover chapter number 9, that is electromagnetic induction. If you understand with the word electromagnetic induction, there are few things we need to focus: electromagnetic and induction. Okay, electro means, can I simply say electron? Okay, with the help of electron, can I say there is a word called current? You need to interrelate everything, huh? Current with voltage, and with the all these things we have the word called electric field. Yes or no? All these things are connected. Fine. Okay, with the magnetic we have a simple word which is called B. Induction means production of current, production of current in opposite direction. Fine. Again, in terms of electro, we need to focus on few things, either on charge. Sometimes we are going to learn about the current, sometimes voltage, and sometimes electric field. Even in case of force, we can use Q, E. These all are the factors which are going to relate with the magnetic field. Okay, so if you remember from the previous days or the term 1 and term 2, as you know, if there is a wire, let's say case 1, there is a wire, okay, and if the current is flowing through the wire, this is your current. Okay, if the current is flowing through the wire, we know magnetic field is produced. Magnetic field is produced in the wire. Clear? But now the same thing can happen, the opposite of this. What is the opposite of this? Can I say change in magnetic field can produce current? Just try to understand. Change in current gives you magnetic field. My question is, can change in magnetic field gives you current? And the answer is yes. And this is the all we are going to learn in this lesson, that what is electromagnetic induction. So what is the short form of electromagnetic induction? Is electromagnetic induction is EMI. What is electromagnetic induction? That process of producing induced current means we are going to produce the current in opposite direction. Okay, let's say with the you can say with the notes, with the help of notes you can understand. So the first part, I already told you, can moving charges produce magnetic field? Yes, we already learned this thing in the term 1. Okay, second part, can moving magnets, okay, or the changing magnetic field, moving magnets or changing magnetic field produce current? Yes, and this is the thing we are going to learn today in this class. Okay, so this experiment means the proof of this experiment has done by, there is the British physicist Michael Faraday, and there is one more American physicist, Joseph Henry. So these two person has made some experiments and prove that if you change the magnetic field, that will produce some current, and that the current name is induced current. Okay, now what is the conclusion of the experiment? Now just focus here. I will use the blue color. Changing magnetic field. Okay, magnetic field is keep on changing, and what it is doing? Generating a potential difference. So means generating a potential difference which is directly proportional to current I. Okay, in a conductor which is strong enough, means we are producing potential difference which is responsible to produce an electric current. Fine. Now we will go step by step to understand this whole process. The first thing, EMI. I told you what is the meaning of EMI? Electromagnetic induction. What is electromagnetic induction? Process. What process? Of generating induced current. Induced current means in opposite direction. In opposite direction. Okay. In a conducting circuit by changing. Okay, there are the factors. You need to focus on this part. Huh? What are the factors? Number one, strength. Strength means magnetic field. Magnetic field, this is the strength. Okay, number two, position. In terms of position, we are changing the area. Third is orientation. Orientation means the angle. We are changing the angle theta. So if we change these three things, either magnetic field, area, or the angle theta, there is a change in the system and the current will be produced. Fine. Okay, now there is a word called flux. Flux means, okay, I will explain you on the next page so that you can relate this. Add a page. Okay, now remove this. Now the word is called magnetic flux. What is the meaning of magnetic flux? Magnetic flux means, let's say there is an area, okay, and how many, let's say this is a magnet. This is south, this is north, and the line of forces are passing. Yes. Okay, remove this one, huh? Because it is crossing. Okay, now the line of forces are passing. So how many line of forces are passing? That is called magnetic flux. So number of line of forces passing through unit area. Clear? So can I say flux? The symbol is phi. Okay, the first factor is magnetic field, which is equals to B. Second is area A, and there is an angle which is called cosine theta. So flux is BA cos of theta. If you remember, I just told you EMI, and I told you there are the three factors. Number one, magnetic field, that is the strength, yes or no. Number two, position, which is the area. Third is the orientation, which is angle theta. So if I combine them together, can you see here what we get? We get the flux, yes or no. Do you understand this part? So if I say change in flux, change in flux give you the result as a induced current. Now till here, do you understand, guys? Change in flux gives you induced current. So, or you can say it gives you induced voltage. Clear? Sure. Okay. So we are going to learn about this thing. So flux is equals to BA cos of theta. Okay, in this I need to add something which is very, very, very important. You should know the word called quantities. Okay, we have the word called vector and we have a word called tensor. Okay, why I'm going to explain you this? You just after 5 minutes you will understand, because I need to relate this with the cases of magnetic flux. Let's say if I say vector A. So how I will write A? This is the magnitude. Okay, and A cap, this is the direction. Fine. But if I write here A vector, which is equals to A, this is your magnitude, and here is N cap, which is the direction. But now there is a major thing what you need to understand. Here the direction is same. Direction is same. What does it mean? Let's say there is a body, and if you apply a force, this is the force vector. Okay, so can I say this is the direction of force? So I can say F vector is equals to F magnitude, which you are applying here, and the direction is the same. Direction is the same. Clear? So that's why it's a vector quantity. This is a vector. But here, what is the difference? What is the difference? You can write here like theta is equals to 0 degree. Here what you can write, theta is equals to 90 degree. Now you will understand what is the logic and what is the other name of this one. If I say magnitude and direction, let's say this is your surface. This is the surface. Okay. So what is the direction of this surface? Can you say the direction of surface is this one, n cap? Yes or no? So it is at the 90 degree of the base. It makes an angle of 90 degree. Similarly, this is the case 1. Okay, let's say case 2. If I make a surface like this, okay, where should be the, or you can just understand your hand. Okay, so where is the direction? Like this. This is your n cap, which makes an angle of 90 degree with the surface. Fine? Clear? So that's why n cap is called normal vector. Normal vector. Fine? Okay, this is a tensor quantity which has a property of scalar as well as vector at one time. I'm going to add a page for you guys, and then I'm going to explain you the concept of magnetic flux. So till now we understand magnetic flux. Magnetic flux. Yes or no? Okay. So we understand phi is equals to BA cos of theta. Now what we need to understand, there are the two factors. B is a vector. So can I say B cap? This is your magnetic field. Okay. A, which is area. This is your area vector. So area vector A is equals to A n cap, because it's a tensor quantity. So you can say n cap is your unit vector, but it's a normal vector. Normal vector. Okay. Now there are the cases, because these cases are going to use in the numericals. So it's very, very, very important to understand. Okay. Now the case 1. Let's say if you have a surface, case 1, if you have a surface like this, and how this type of surface will come in your numerical. Okay, so I'm going to write that when magnetic field is perpendicular to the surface, you will get this same statement in the numerical. Okay, they will give you that magnetic field is perpendicular to the surface. How you are going to solve this situation? Let's say this is your magnetic field. Yes or no? So what is the angle here? 90 degree. But there are two things. One is A, which is called the area. Yes, and one is n cap, which is the direction. Now this is very, very, very important, what you need to understand. Okay, B makes an angle of P. B is magnetic field. Okay, so B makes an angle of theta of 90 degree with A. Do you understand? With the surface. Do you understand? Now my question is, what is the angle between? What is the angle between B cap and N cap? Okay, this you understand, this is your B cap. But where is the N cap? Tell me. This is the surface, and I told you n cap should be like this. So B cap is like this, n cap is like this. So what is the angle here? Can I say both are in the same direction? Angle is 0 degree. Yes or no? it is making an angle of 90 degree. Perpendicular means theta equals 90 degree. With whom? With surface, not with direction. It is making 90 degree with the surface. Fine guys, clear? So if you solve the flux, what is the flux? B A cos of theta, and theta is the angle between B cap and N cap. Is it clear? B cap and N cap. So I can solve flux is equals to BA cos of 0 degree. So which is equals to BA. So it is called maximum flux. Fine. Clear? Okay, now case number 2. This is very important, guys. So at least if you don't understand, you have to review it 2 times, 3 times, 4 times. You have to make some mastery, then go for the numericals, else you will get confused. Okay, now the case number 2. Let's say when the magnetic field, case number 2, when magnetic field B is parallel to the parallel to the surface. Okay, first of all, you need to understand. Let's say this is your surface. This is the surface. Okay, how? Parallel means, okay, can I draw like this? This is your magnetic field. This is the B vector. So can I say here is your B cap? Fine. So you can say, what is the angle here? With the surface, parallel means theta equals to 0 degree. So can I say B and A? A means area and B is your magnetic field. So what is the theta here? 0 degree. Fine. Okay, now just tell me, think and tell me. This is your surface. Okay, so where is the angle? N cap. This is your N cap. Yes or no? This is the first part. Second part. So do you understand? This is your B cap and this is your N cap, perpendicular. So making an angle of 90 degree. So theta is equals to 90 degree. So flux is equals to BA cos of 90. So cos 90 is 0. Flux is equals to 0. This is called minimum. Fine guys, do you understand? Sure. Okay, now this is the case number 3. What you need to understand, that is most important, which will kill your brain. Okay, let's say there is any angle theta, any angle theta between magnetic field and surface area. Okay, what you need to understand, let's say there is a surface, okay, and let's say this is the magnetic field is going. Clear? So let's draw the diagram. Okay, so it is making any angle theta, let's say you can say 30 degree. So where is the N cap? Where is the N cap? Or what is the real angle you are going to use? So with N cap and B cap, your angle is 90 minus theta. So if 30 is given, so what you need to do? Theta is equals to 90 minus 30, which is equals to 60 degree. So flux is equals to BA cos of 60 degree. This is very, very important. And in lots of numericals, you will get this thing. Clear? So, how to solve all these things? Now you understand? Okay. So, we are solving flux, which is B A cos of theta. So, what is the unit? If you solve it, the unit is SI unit is Weber. SI unit is Weber, or you can say Tesla meter square. Tesla meter square, or you can say Joule per ampere, or you can say volt second, and the dimensions are m1, l2, t minus 2, a minus 1. Clear, guys? Till here, I thought you will understand what is the concept of magnetic flux and how you need to solve them. Clear? Okay.